Good morning. My name is Ed Smith. I am a professor of aerospace engineering here at Penn State. I have also been serving for many years as the group leader of the Center for Acoustics and Vibration Rotorcraft Acoustics and Dynamics group. So I'll just share a few overview charts with you this morning, and then I will turn it over to focus on one of our more exciting ongoing research projects. So our group consists of a number of faculty from several different departments, in addition to myself, who work mainly in rotorcraft dynamics, vibration control, aeroelasticity, things like that. We have my colleagues from aerospace engineering. Joe Horn works in flight mechanics and dynamics of low frequency vehicle phenomenon. Ken Brentner works in computational aeroacoustics, rotor noise in particular. Jose Palacios works in testing and evaluation of advanced concepts, ice protection systems, and smart structures. Jinhua Song works with me in rotor dynamics. You know Steve Conlon, perhaps, from structural acoustics and structural dynamics. Chris Ron's in the mechanical engineering department. He's been working collaboratively with me on rotorcraft problems relating to structural dynamics and control for many years, and several members listed additionally. I want to focus on our newest member is Assistant Professor Eric Greenwood, who started at Penn State about a year ago. So Eric came to Penn State from about a 10-year career at NASA Langley Research Center, where he was heavily involved in the rotary wing aeroacoustics and aeroacoustics department in general. He received his PhD from the University of Maryland in 2011, and like I said, spent about just under 10 years at NASA Langley. His research is focused on enabling low noise operations of rotorcraft in and around communities, conducting experiments to understand the physics of noise generation, developing fast and accurate noise models, exploring real-time aeroacoustic models, and how they can be applied to provide aircraft with acoustic awareness to enable low noise operations. So we're excited to have Eric on board. We also have about 10 or 15 graduate students pursuing master's and PhD degrees, working with all of those faculty on problems specifically related to controlling interior noise, exterior noise, and improving the structural dynamic and vibration control environment of everything that goes on board a rotary wing aircraft or vertical flight capable aircraft. So this is more for your reference. The charts are included. I won't go over all of these names and thesis topics. I would like to highlight Raja Zaharunian, who will be giving on a separate presentation his interesting talk from a recent conference about acoustics and performance of coaxial rotors. We've had several students graduate in the past year. Several of them you have heard from in CAV reviews in the past. So if you're interested in keeping tabs on them, just feel free to contact me and I can connect you with them. They're all gainfully employed, happy to report. And this also gives you an idea of what kind of research they worked on. So there's a lot more information where this came from. One of our large programs within the group continues to be the Vertical Lift Research Center of Excellence. We're currently in the 5th year of a 5-year cycle of tasks that we started back in 2016. So you've heard about highlights from many of these projects over the last 4 years. These are just some of them that I would say are related to noise and vibration. Right? This Rotorcraft Center or the Vertical Lift Center as a whole covers many different topics: aerodynamics, propulsion, flight controls, autonomy, ice protection, and so forth. But noise and vibration have always been very central to our program. So we have a task continuing relating to the quantification and study of the unsteady aerodynamics behind the hub of a helicopter, right? So you can see a top view of a hub over here in this chart, or a coaxial hub CAD view here. We put a number of those model scale hub systems into both our water tunnel here at Penn State, and we've also been working collaboratively with CFD simulations of these hub flows at the University of Tennessee with Professor Jim Coder. Basically how this evolves into a vibration-related task is all of this separated flow behind the hub of the helicopter basically is a tonal and random noise excitation to everything aft of the hub, like the horizontal and vertical tail and tail rotor. So a major source of vibration has been challenging designers for many, many years. So this project has made a lot of progress and a lot of publications and graduate theses. Ken Brentner and Professor Sung-Kyu Lee out of University of California have been doing a fundamental aeroacoustic study of coaxial rotors. So rotors with hubs like this, where the blades rotate in opposite directions to prevent the need for an anti-torque system and also avoid the retreating blade stall effects at high speed, have a lot of unique aeroacoustic phenomenon, and Ken and Xiangqiu have been studying those in great detail the last 4 years. I have been working with a number of my graduate students, along with Professor Chris Rahn and Professor Chuck Bacus, on trying to find ways to increase the damping or energy dissipation of the rotor blade structurally, particularly in the lead lag direction, which is the rotor motion in the plane of the rotor, right? So the rotors tend to flap up and down when they rotate, or they're designed to, and also lead and lag in the plane of rotation. So the lead lag mode is notoriously low damped with very little aerodynamic energy dissipation. That requires some mechanical means of dissipating energy, and we've been looking at using nanocomposites as well as devices called flexible fluidic matrix composites. Cliff Lissenden continues to work in the domain of nonlinear laser ultrasound related to improving the quality control and in situ fabrication of additively manufactured parts. That is supported out of our Rotorcraft Center because of the increasing interest in additive manufactured parts within the helicopter industry. We also have heard in past years and seen some very good quality posters from Dr. Umberto Saetti, who recently graduated under the advisement of Professors Joe Horn and Jacob Ensiu. And they're talking about research related to alleviating dynamic loads, as shown in these pictures on the right, using the flight control system as a load limiting controller to avoid have damaging maneuvers that the pilot may inadvertently get into and cause fatigue damage on components. Ken Brentner also works on an acoustics prediction tool, a rapid prediction tool to be used in conceptual design. So he can talk with you more about that program. This also gives you a bit of an overview of some ongoing noise and vibration projects. We work with the FAA on noise abatement, modeling and procedures. That's a program led by Professor Ken Brentner with collaborations with companies such as Bell and Sikorsky and Continuum Dynamics. Steve Conlon and I have been working with our graduate students on acoustic black holes, specifically for reduction of interior cabin noise on the helicopter environment. Jose Palacio has been working on passive balancing for rotating supercritical shafts, and we heard from some of his graduate students over the years, and I encourage you to take a look at the graduate student research topic list. Continues to be a very vibrant area for us. Just alert you to another interesting project. I wouldn't say it's a noise program, but it does involve quite a bit of vibration prediction and control. Last summer, a group of Penn State faculty, Jack Langelen, Sven Schmitz, and Jose Palacios, working in conjunction with Johns Hopkins Applied Physics Laboratory in Maryland, were awarded a very large, very exciting program, essentially to fly a drone about the size of a small car on Titan, which is the moon of Saturn. And this mission is called the Dragonfly mission, the Dragonfly Project, and there's a lot of information about that program. It's very exciting to us, a very long-range, long-term program. The vehicle won't be set to arrive on Titan until around 2033, right? So there's a tremendous amount of design and analysis, simulation, and ground test work that will be going on between now and the launch date in 2026. That's all I have to share with you today. I'd like to encourage you to check our other recording for Raja's presentation on the experimental characterization of antiphase asymmetric rotors. Thank you very much and enjoy the CAV workshop.